Kishore sir.
Yes, sir. Good morning.
Sir. Good morning, sir. We'll wait for 5 more minutes, sir.
Okay, no problem, sir.
Okay, thank you, sir.
And sir, the thing is, actually, I'm having another session by 12:30. Actually, I can
Okay,
extend
sir.
that.
No problem. Just 2 more minutes, 3 more minutes.
Okay, sir.
Okay, sir. Thank you. Good morning, all of you. On behalf of Chalapati Institute of Engineering and Technology, Department of Computer Science and Engineering, I welcome you all for the guest lecture on computer networks. Today's resource person is Mr. M. Krishna Kishore, working as assistant professor in Malareddy University. Previous experience of Vasavi College of Engineering, Hyderabad for 5 years, and Narayana College of Engineering, Nellore 6 years. Industrial experience 1 year in Tata International Limited. Graduated from JNTU Anantapur in 2014. He has overall teaching experience of 11 years and industrial experience 1 year. He has around 5 international journals, 1 national journals, and he has participated in 1 international conference, and he has 1 patent on his name. So he has given different virtual guest lectures in Andhra and Telangana. He is a lifetime membership of ISTE and IAENG. So thank you so much, sir, Krishna Kishore sir, for coming as a resource person for this guest lecture. Over to you, sir.
Thank you, sir. Thank you very much. Okay, good morning, students. Good morning, participants. Myself already, sir, given a very good, nice introduction about me. Thank you, sir. Thank you very much for your introduction. And I'm introducing myself that I'm Krishna Kishore, working as an assistant professor with 11 to 12 years of experience in teaching and industrial. Today, we are going to discuss about computer networks. Actually, it is not that much easy to complete. To give the detailed description about computer networks in 1 hour, it may take months. Of course, if you are attending for any workshop section or like that, also it will take at least 1 week to 10 days. But thank you for giving this opportunity at least for 1 hour. But I will give how much I can in this 1 hour. Okay. Meanwhile, if any people wants to ask anything, you can raise your hand and you can ask anything. Of course, with the help of according to your rules and regulations. Okay, let us start the introduction. Before going to the start about discussing about the computer networks, I like to say, sir, is my audio is
Yes, sir.
I'm audible. Okay.
Yes, you are audible and visible.
Yes, sir. Thank you. Excuse me. Okay. So before going to start about the computer networks, let us discuss. Let me say what actually computer and network. We know that computer is an electronic device which is used for human interaction. A network is nothing but collection of autonomous computers. Collection of anything, we can call it as networks. Either it may be cable connection or it may be any type of communication where two or more devices are connected. But we can define computer network as a collection of autonomous computers interconnected for information exchange. Computer network can be defined as collection of autonomous computers interconnected for information exchange. So there is a difference between this connection and interconnection. We can say any two devices are connected if the data flow is in one direction. But we can say any two or more devices are interconnected whenever the data can exchange between the systems. Both the systems, how many systems are there? Every system can have the capability to share the information and to receive the information. Then only we can call it as interconnected. So that is the difference between connection and interconnection. That's why we are calling computer networks as autonomous computers. We are defining computer network as autonomous computers interconnected for information exchange. We can exchange the information, and here the network will not bother. The network will not bother about the errors or any data mistake. Any data entry mistakes or any programming execution errors. It will not bother about those things. Computer network is responsible only to transfer the data from source system to the destination system. Whether the data or the file may be corrupted file, or it may be corrupted file, it may be an executed file, or it cannot be executed, it may be error file. Don't mind. The network is responsible to transfer the data from one system to another system. I will give an example. For example, if you are opening one PDF file, the PDF file extension will be .pdf, and you are saving that file as .doc or .mp3 like that. So actually, if you are saving any PDF file with the .mp3 extension, if you open that file, it will not execute in your system. Why? Because MP3 software will not execute this PDF formatted file, right? So this is the error at the programming side. But coming for the computer network, whether you saved the PDF file with MP3 extension or with any other extension, or there are any errors or any exceptions, it will not bother whether you are transferring the data or not, and whether whatever the data transferred from source side reaches the destination side or not. This is the only responsibility of the network to check how to transfer the data. While transferring, there are so many protocols, so many methodologies and rules, regulations to be followed by the source system and the destination system. So all this comes under the computer network subject. So before this is about definition of the computer network, but actually before discussing about the computer networks, I like to say the history. Just we will reveal the history. In our past centuries, one century is 1 second. If you see the last 3 centuries, one century is dominated by one new technology. Like for example, in 18th century, it was in a whole century, the people were looking about the mechanical systems, and it was the industrial evolution. And whenever you coming for the 19th century, the century is the age of the steam engine, and how the steam engines must work and how to utilize that one. What is the complete era of the 19th century is about steam engine. But whenever you entered, we means whenever 20th century entered, the key technology was information gathering, processing, and distribution. Please remember, information gathering, processing that information, and distribution is not a small thing actually. So the information gathering became a major role in 20th century, and gathering information is one module, processing that information is another module, and distributing of this information is different. So there are in the 20th century, whether we are having the information, it is not that much easy to process and to distribution. We have to follow, I mean, the technicians must follow the three different categories and three different methodologies for gathering and processing and distribution. But among other developments, we saw the introduction of the worldwide telephone networks, like the invention of radio, television, birth and unprecedented growth of the computer industry, the launching of communication satellites, and of course the internet. As a result, this rapid technology progress, these areas are rapidly converging in the 21st century, and the differences between collecting, transporting, storing, processing information are quickly disappearing. I mean, what I want to say is, in the 20th century, the key technology is information gathering, processing, and distribution in three different methodologies. But whenever we came for the 21st century, all these things are disappeared. Means just information is important. I will give one best example. In the earlier days, to watch any movie, to watch any video, it is not that much easy. We should, first of all, we should gather that information either from internet. We will download that video file. And if you want to process, that is nothing but if you want to execute, we have to keep it in separate players like VCD players or DVD players or in the computer. And with separate processor, we're supposed to execute those things. And if you want to distribute, we will distribute that video file either by internet or by pen drives, USB drives, CD drives, like that. But in nowadays, if you want to watch a movie, directly you can open in the internet, you can you can watch the video from the internet itself. Means information gathering and processing and transporting and storing, everything is at the cloud side only. So because of this wide spread of this 21st century, all these, the difference between collection, transporting, storing, processing information are disappeared. Means no need to collect. If you, in earlier days, we're supposed to use the Walkmans to listen music, or later on we used all of us used iPods. And now no need of iPod, no need of separate device to play those MP3 devices. Just we will open like Spotify, Ghana, some websites are there. So simply we will go through that websites. I mean, we can directly play the music or we can directly watch the movies over there. Means here, whatever the information is there in the server, directly you are executing in the server only. You are watching the movies or you are listening the songs only because of internet, right? You are not gathering and you are not storing that information in your system, in your mobile or in your iPods. Directly, you are utilizing that thing. So the rapid development in the 21st century is about the information. If you have the information at the server side only, they will support you to execute the data and no need to store in your device, but they will store the data in the cloud. And whatever the thing you want to process the data, no need to worry about that. Just you need the information and they will gather the information. And if you gather the information, you can upload in the servers like that. You can open YouTube channel and you can save your videos in YouTube, or you can save in your Facebook network. I mean, in social media like Facebook or Insta, like that. So whatever the things are going on right now, just your system should support your system should support about these things. If your system is having that much good configuration, definitely no need to worry about that. You can utilize the data and you can execute the data from the server only. So, one second. So, whenever we're discussing about this computer networks, the old model of a single computer serving all organizational components has been replaced by one in which large number of separate by interconnected computers do the job. These systems are called computer networks. So another definition for this one. So the main need of the computer network is, in earlier days, even in your institution or in my institution, in any education institution or organization, if the person wants to access the data, they will use some computer with hard disk or some server space in the lab or in the college, in the institute, and whatever the data they need, they will store there only. And if the person wants to access the data, the administrator has to go to that system and then only he can process. But because of this internet, the person no need to go to the college. directly he can access the data present in the server from his home. This is how, this is why, because of the this is because of the computer networks. In earlier days, if they want to share any information, it is must and should to go to the server, and there they can access, or from there they can distribute. But now on, from today, in nowadays, we are accessing the data, and the administrator is, if you need any messages or any mails, any WhatsApp messages, or any mails, for example, tomorrow, because of a so and so reason, tomorrow there is so and so problem, so we are declaring holiday, like that. If the government declares any holiday, so simply they are distributing that message from the system only, but they are accessing that system from their home instead of going to the institute. This is because of computer network. So computer network means a collection of autonomous computers interconnected by a single technology. Two computers are said to be interconnected if they are able to exchange information. The computers on a network may be linked through cables, telephone links, radio waves, satellites, or infrared light beams, like that. So computer network can be linked either by, we can make a computer network either by using the cables, or by using the telephone links, or by using the radio waves. You know about radio waves, right? Radio waves, satellites, or infrared light beams. So different types of medium. By using these different, you people better know about satellites, and you people know about cables. Why? Because you people are using cat 16 cable, I think, for optic fiber, like Act Fiber Net, Geo Fiber Net. All these fellows will use the cables, right? And telephone links. In earlier days, internet was used with the help of the telephone communication network only. So right now, so many private companies are there, and they are providing the internet by using the optic fiber because of technology. But in the earlier days, whenever internet came into the existence, instead of constructing separate network, separate communication thing, whatever already established communication was the telephone communication links. By using same telephone line and telephone network, people were supposed to transfer the data by supposed to use the internet by using those telephone communication system only. Okay, devices in network are connected using a wired or wireless transmission medium such as cable or air. We can connect the devices. We can connect the devices either in wired or wireless communication. Someone is raising hand. Is there anyone? Someone is raising hand. Do you want to ask anything? Okay. Shall I continue?
We take the question and answer at the last, sir. You can continue.
Okay, no problem. No, okay. Someone raised the hand, so I thought that okay. Let it be. Thank you, sir. Okay, we can use the medium either cable or air. If you are using a cable as a medium, we can call it as the wired communication network. And if you are using air as a medium, we can call it as wireless communication network, just for transmission of data. So there are some rules, and for anything, there are some set of rules are there. Like for a student, it is must and should to wear ID card, like that. So there are some rules and regulations are there for computer network. Information must be delivered reliably. Here, what the reliably means, trust. Whenever source send the data to the destination, whatever the information is transferred from the source, the network has to provide the reliability to the user. Then only the user can trust the network. So reliability, you know better about this Reliance company. Do you know the meaning for Reliance? In general, the meaning for Reliance is trust. For example, Ratan Tata, whatever the industries is having, he kept his name, his surname like Tata. For Aditya Group, they are using Birla, like that. But coming for the Mukesh Ambani and all the Mukesh Ambani and Anil Ambani, Dhirubhai Ambani, they are using the name called Reliance. What actually Reliance means, it's nothing but a trust, reliability, trust. We are providing trust, like that. With that name, they came to the, okay, it's another different issue. So reliability means providing the trust for both the source system and the destination system, saying that whatever the data sent exactly reach the destination. This is the first rule. And next, coming for whatever the information must be delivered should be consistently delivered. It means it should not be changed. Whatever the data you are transferring, the same data should reach. Multiple computers must be able to identify each other. So from which system the data has received, and from which system the data to which system the data is delivering. So whatever the systems are connecting, each and every system must be identify each other with their IP address. We will use the IP address for identification. And by using this computer network, there are some benefits like network can increase in efficiency. So the person, if for example, if any program wants to execute, we can execute the same program in the lab by distributing them into the modules. Whenever you become a software employee, you people will better understand about that. Why? Because these IBM and all those companies, what they will do is, if they want to develop any project, they will divide those projects into modules like testing and developing, code making, like the designing. So one person, one developer will do the designing, another fellow will do the testing, and another fellow will write the code like that. And finally, all these fellows will communicate at one place. The team leader will check through one common software, and there we will collect all the information. So here, if you use if there is no network, all the things must do at single system one after other. So here simultaneously all the people are working for the same cause, right? So this was because of this thing, efficiency is getting increased. It can help standardize the policies, processes, and processes. It ensures information consistency and integrity. It ensures information security too. These are the benefits of the network. So whatever the standard policies are there, for example, there will be one common website. I don't know, just I don't know whether there is one common standard policies are there for each and every company, for every institute. For example, for us, there is ERP. ERP means it's nothing but a local means local IP address network, where we can enter our attendance, and students can see their marks, and if they want to ask any queries, they can ask like that. So this is local. Whatever the rules and regulations are there are standardized for this network. They cannot the people who are studying another institute cannot follow the policies of there are different. So whatever the standard policies, processes are there, we can follow the same thing by using this network. Information consistency is the main thing. The information will not change, and integrity is the best benefit from the computer network. And it also ensures information security. Whatever the information you are passing, it is secured. So how they will be secured is because of by using layered technology. We'll discuss later. So information security is one of the another most benefit. And excuse me. And next, coming for different types of users, like simultaneous access to data, file server content documents which are used by other computers, personal communication by sending email, conferencing via over IP, data file, software, hardware resources. So just now we discussed about the IBM, right? So in the IBM, the people are working simultaneously because of the network only. And of course, we can use the network for our personal communication, like sending emails, conferencing, video call, whatever we are right now we are speaking it. We are taking one session in the Zoom. All this is because of computer network only. So server, and there may be so many clients, they can connect to the server, and server will act as a master for them, and clients will act as a slaves for the server. And coming for the applications of network, there are different types of applications are there. We can use this computer network in different thing, like resource sharing. Wherever you need to share your resource, there we can use the computer network. Like the resource may be hardware, or it may be software, like computing resources, disks, printers. There is one printer, and of course, if you go to the Xerox centers and internet caves, there will be only one printer and Xerox machine, and you can give the printout from any of the system which was connected. So you are sharing the hardware resource to all the computers. And of course, software, application software. Zoom, the best example. Zoom is one software, and we are sharing the Zoom as a resource from my side and from your side also. And information sharing, easy accessibility from anywhere, files, databases. So computer network can use wherever accessibility is easy. For example, there is a database regarding your Chalpati College of Engineering, and there is one database where your roll numbers, your results, everything will be there, and you can download your data. And of course, you can download your data from the website. So this is nothing but that is nothing but sharing, accessing such capability with the help of World Wide Web. Of course, we can, whenever if you want to search anything in the internet, you will go through www. That is nothing but World Wide Web. World Wide Web. World Wide Web. So here, why this www came into the existence, it will be discussed in the, if web technology subject is over for you, you may understand this thing. Actually, I have to give you say you small story regarding this World Wide Web. So to access the information in the internet, there are some protocols like HTTP protocol, HTTPS protocol. So we will use that hypertext transfer protocol to access the data which is present in the internet. With the extension, before starting the domain name, we will start the website name with the www, World Wide Web. We know what is World Wide, and we know what is web. Actually, we are accessing the data in the internet. Why can't we call it as World Wide Internet? Why we are calling it as World Wide Web? Because you know, the first network in the earth was designed by a spider. You people may see this spider views a web. Generally, spider will views a web. How beautifully it will views that web, you know. It will at one place, it will be the spider will weave one web, And if any insect come onto that web, it will pass some poison like liquid from another side. Means, for example, there is a web and the spider will stay at one side. If any insect come and fall on that web, simply it will send a poison like liquid through that web from spider to the insect. That bug will, of course, it will not die. It will, it will, it will sleep for some time. At that time, the spider will goes there and then it will eat that insect. So for that purpose, why it has to pass all this thing is because of the digestive system of the spider is very, very less. I mean, it is not that much speed. It is very, very slow. It will take 16 to 18 hours to eat one insect and to digest that one. So meanwhile, that bug will can run away from that. So for this thing, this what the spider will do is it will construct a web. Whenever bug comes and fall on that web, it will send some poisonous like liquid. The bug will be faint and then it will go to the bug and it will eat. So the first, it is transferring the data from one place to another place. From one place means where the spider is there, and to other place means where the insect is there. So it is transferring the data. That is nothing but poison. So it is the spider is the first living thing which constructed a network. So because of that thing only, instead of calling worldwide internet, we are calling it as World Wide Web. What is internet? Internet can be defined as network of networks. There is one network in college. There is one network in another institute. There is one network in home. There is one network in office. All these networks are connected. We are calling it as internetwork. So internet is nothing but network of networks. So why can't we search why can't we browse with the WWI, Worldwide Internet? Why we are calling it as World Wide Web? Because the first network channel was designed by the spider only. That's why they are keeping World Wide Web as its name. Okay, so it's another story. If if any CSC people are there, you people can understand about this thing. Why? Because in web technologies, your faculty will explain about this thing. And coming for the communication, we can use whenever if you want to transfer the data either through email or message broadcasting, we will use the networks. Remote computing. Remote computing means server is at one place that can be accessed from another place. That is called remote computing. Distributed processing. It's a grid computing technology. It's a different type of technology. But distributed processing means distributing the data. There is only one memory and one processor we can access from anywhere. In my college days, instead of having separate computers, they were supposed to keep only monitors, monitor, keyboard, mouse, and there is only one processor, one CPU. Whatever the data, if you want to access, we can process the data. We need a processor, right? So whatever the data we are giving as input to the system, the data input will go from my monitor to the processor and it will execute, and it will give the data. Of course, distributed processing is one. This is one type of distributed processing. In such a way, the processing can be distributed. The processor can be used, the memory can be used. So many DSP, distributed processing, there is another subject. It is different actually. so many technologies are there. Let it be. So wherever you need distributed processing, we need a computer network. And coming further, the most important thing called network topologies. Generally, we can define topology as nothing but a shape of a network. Topology means shape of a network. Logical layout of files and equipment is called a topology. Generally, in simple terms, we can call a shape of a network. So the way in which devices are interconnected to form a network is called a network topology. So how you are connecting the systems, whether you are connecting one by one, whether you are connecting in a round, in a ring, like that, depending upon the shape. Here, instead of calling network shape, we are calling network topologies. That's it. Topology is nothing but shape of the network. Some of the factors that affect the choice of why we will go for particular topologies because of cost, scalability, flexibility, reliability, ease of installation, ease of maintenance. Depending, there are so many topologies. If you feel this is cost, you will go for another thing. If you feel this is slow, but I need more speed, you can go for another topology. If you feel this is flexible, so with which topology you are flexible, you can use that one. Reliability depends upon the requirement. So in such a way, there are different topologies are there, like bus topology, hybrid topology, tree topology, mesh topology, star topology, ring topology. So these are systems. So 1, 2, 3, 4, 5, 6, like that. Multiple systems are connected through a common cable. We are calling it as bus topology. If all the systems are connected in a ring wise, we will call it as ring topology. Star topology means there will be one person acting as a master and other fellows will act as his slaves. Mesh topology means every system connected, every individual system has a connection with another individual system. Tree topology, there will be one head, two leaves, router, this is the root, subpart, and next subpart, like that. Hybrid topology. If you are making two or more topology combination, then we can call it as hybrid topology. So many benefits and losses are there. I will give you the brief description about that. In the bus topology, in this shape, if there is any problem in the network at one place, the entire thing cannot be, for example, if there is any problem here, so the system cannot send the data to another system. In like the so coming for the bus topology, it is also called linear bus. One wire connects all the nodes. The main advantage is easy to set up, require less hardware, low cost. Only disadvantage is very slow, easy to crash. If one system affected, remaining system cannot communicate with each other. For example, if there is any disconnection here, so we cannot transfer the data by using this path. So this is the disadvantage, and coming for the advantage, it is very easy to set up. Very less hardware also required. For example, only one cable will be there. We can connect to how many systems we want. We can connect to those systems. I'm coming for star topology. One master with the different slaves, whatever. For example, system 1 wants to send the data to system 2. Definitely, you should pass the data by using main system as a medium. So he can send whatever the data he wants to send to this system. He will send some data. This client will ask the server, please send the data, or please receive the data. Like that, they will be connected. So master slave connection. And coming for the ring topology, flow of messages will be in one direction only. For example, if computer 1 wants to send the data to computer 2, simply can send like this. If he wants to send the data to 3, this will flow from here to here. If you want to send the data for 4, system number 4, it has to pass among all these lines. So like this. So this is one type of shape. Of course, there are some advantages like a very high transmission speed possible. Small cable segments are needed to connect two nodes. One system is connected with another system. Simply we can connect easily. Disadvantage is if one node ring get breakdown, the whole network will cause damage. And coming for the tree topology, one bus is connected with various trees. So for example, one master is one master containing multiple slaves. Here one node is acting as master and some nodes are acting as slaves. Here one node is acting as master, some slaves are some systems are acting as slaves. If we connect all these things, we can call it as tree topology. For example, the system in segment, the client system in segments 2 wants to send the data. Simply he can use this master as a medium and he can send the data. If the system wants to send the data to the segment 1, first he will send to his head, then this route, and segment 2 will send to the segment 1 head. Then they will transfer the data. For example, if any of the student in your department wants to speak with your HOD, directly you can make a communication with your head of the department. And if you want to meet if you want to talk with another staff, or if you want to exchange any information with the help of your faculty, you can make a communication in the lab with other system. But if you want to make a communication, or if you want to ask anything with other student in another department, first of all, you will go to your HOD, and your HOD will make a communication with other HOD. Then he will access, when he grants the permission, then only you are allowed to transfer your data to other department system, right? Like that. This is one type of shape. And coming for the mesh topology, here each and every individual system will make a communication with all the systems. This is one type of shape. So of course, this is very helpful and useful. Why? Because if system 1 wants to send the data to any system, he can send the data directly. Coming for the hybrid. In hybrid topology, multiple, for example, here this is ring topology, and this is star topology, and this is also star topology. Multiple different types of shapes of networks are connected by using one switch or one modem. Then we can call it as hybrid topology. Okay, that is about the shapes of the network. And coming for the hardware, network hardware can classify either by transmission technology or by scale. So many people having one myth that if you are asking about the network hardware, simply we can say that we can connect the systems in the lab like LAN, MAN, WAN. Simply they can say like that. Some people are having myth, but actually network hardware is divided either by transmission technology or by scale. If he wants to know about the transmission technology, if any one system wants to send the data only one to other system, there are two types of transmission technology. They are widespread. One is broadcast, another one is point-to-point links. Broadcast means If one system wants to send the data to all the systems at a time, we can call this system is transferring the data to all the systems. So we can call it as broadcasting technology. If the one system wants to send the data only to another single system, we can call it as point-to-point system, and it is called point-to-point links. In point-to-point, we can use the term called unicasting. Unicasting means one system connecting with another system. We can call it as unicasting. One system connecting more than one, like 2 or more systems, we can call it as multicasting. If one system connected to all the system, we can call it as broadcasting. So that's why BBC, British Broadcast Channel, why they, whatever the Gemini TV, ETV, Marti, whatever the TV channels are there, they will broadcast. Means only one Gemini TV channel network is there, or Marti TV channel is there, and they will broadcast whatever the content they are having to all the users. That is broadcasting. And unicasting means if any single system sends the data to another system, then we call it as point-to-point. And I am remembering you one more thing: the disconnections. These connections are not interconnected; they are connected. Why? Because in the TV we can watch whatever the program you want to watch, you can watch. But if you want to ask anything, you cannot ask. For example, if any news reader reading the news, you can listen. You cannot ask a doubt to the reader. Why? Because it is only one-way communication. That's why we cannot call it as interconnection. We can call it as connection. Okay. So all those are broadcasting. They can send from a source. They will broadcast all the data, whatever they are having, to all the users. And point-to means one-to-one connection. And that we can also call it as unicasting. In contrast, of course, broadcasting system usually allow the possibility of addressing a packet to all the destination by using a special code and address field. This mode of operation is called broadcasting. Some broadcast systems also support transmission to subnet of the machines, which known as multicasting. So here again, no need to confuse. For example, in your lab, there are 60 or 30 systems are there. So each and every system will contain its own address. If one system wants to send the data to all the 29 systems, no need of address, simply they can send the data to all. If the one system wants to send the data to only one system, he must know the address of that system. System 1 must know the system 9's address, then only he can send the data. We can call it as unicasting. If the system 1 wants to send the data only from group of systems, among 30 systems, he wants to send the data only to 10 systems. So he will select those 10 addresses and he can send the data. In our WhatsApp, if you want to send the data to only one person, it is point-to-point communication. If you want to send the same data for 3 to 4 members, you will select 4 to 5 contacts and you will send the data. It is multicasting. Coming for the broadcasting, that is nothing but if you share any information in the group, the information will be shared by all the fellows. Whoever wants that information, they will receive, they will access. For example, there is one WhatsApp group of your friends or your colleagues or your, for example, there is one WhatsApp group for your section. And in the group there is a message: students who had not submitted assignment, please submit now. If your class faculty shared such information in your class group, those who have not submitted the assignment, they will react for that message. Those who already submitted the assignment, they will not take care of that. So in the broadcasting, this will happen. You will send to all, but the data will be transferred to all the systems. But which system needs the data, only that system will access the data. That is about the broadcasting. And multicasting means only to sending WhatsApp is only one example, but coming for the multicasting, to how many systems wants to send the data, you can send to those systems. And next, coming for, depending of course, scale. One is transmission technology, another one is scale. Scale is nothing but distance. So if you are making the network in 1 square meter, we can call it as personal area network. The best example is our personal computer, keyboard, mouse, CPU. We are connecting all these things either with wired communication or wireless communication. But we are forming a network. Mouse is one device, keyboard is one device, printer is one device, CPU one device, monitor is one device. All these devices are using by some common network. Here we can share the information from one device to another device. So we can call it as personal area network. And if the distance contains 10 meters to 100 meters or up to 1 kilometer, we can call it as LAN, local area network. We can construct a lab by using this cable, only by using this wired or wireless communication. If you are communicating any number of systems in 10 meters or 1 kilometer up to 1 kilometer, we can call that network as local area network. So in the lab, generally it will be local area network. And if you are connecting the systems more than 1 kilometer, that is up to 10 kilometers. But right now, latest technologies says that up to 50 kilometers. If you are making communication only within the city, With that network, we can call it as metropolitan area network. Earlier it was 10 kilometers. Of course, recently I read in one article that man was extended up to 50 kilometers. And if you want to connect the systems, 100,000 or like that, we can use a network called wide area network, like country or continent. By using wide area network, we can transfer the data, and we are calling it as internet. Internet means network of networks. Wide area network means one big wide area network, one wide area network in whole. For example, there is only one wide area network called Act FiberNet, GeoFiberNet. Like that, we can call them as wide area networks, and they will make a communication with the internet. Internet means, you know, that intra means within, inter means outside. Intra sports competition will be held within your college. Inter sports competition will done with your institution with another institution. Inter means not this and that one, like that. So here, in all these wide area networks are connected with so many number of systems with the help of the internet only. Why? Because this one network and another network, this inter-networking will transfer the data from one system to another system, like that. And this is about example like personal area network. We can connect these devices either by wide communication or wireless communication. And coming for the local area network, a LAN is privately owned network that operates within a nearby single building or like home or office or factory. When LANs are used by the companies, they are called enterprise networks. Of course, there are wireless LANs also, where there is no possibility to construct the cable. Then we will go for wireless networks. But whenever you are establishing wireless LAN, it is must and should we need a separate device called access point. Of course, we will call it as wireless router. That is nothing but Wi-Fi device in your college or in your home. Whatever the modem is there with antenna, we are calling it as wireless router. So it will relay the packets between wireless computers and also between them to the internet. So whatever the router, how many, for example, there is one Wi-Fi router is there, 5 to 6 devices are connected to that router. And if you want to share the information within these 5 to 6 devices, you can share. Or else, if you want to share the information through internet, you can also show if that router is having internet connection, right? If there is no internet, simply you can make a small wireless communication and you can share the information, right? For example, there is no internet, by Wi-Fi router is there. Casting, you people may have better idea about casting in we can cast our mobile device with the TV, smart TV, so that we can watch the videos which are present in our mobile in the TV. That is nothing but without internet, we can make a connect, we can connect the devices. There is a standard for wireless LANs, that is 888.802.11. This is the standardization for wireless LAN. Popularly, we will call it as Wi-Fi. So another thing is nothing but wired communication. Of course, it runs at the speed anywhere from 11 to 100 Mbps Wi-Fi. Whereas wired LANs are range different transmission technologies like copper wires, optical fibers, and LANs are restricted in size. The topology of many wired LANs is built from point-to-point links. That is nothing but IEEE 802.3. So wireless, we are calling wireless LANs as IEEE 802.11, whereas in wired communication can call as IEEE 802.3. Of course, popularly we will call it as Ethernet. If you open any system in your lab and if you check for internet connection, so some system device will be there. No, if you click on that, it will show the status of Ethernet, not internet. Why? Because every system, if it is connected through cable, it has to make a communication with Ethernet. If this Ethernet is having communication with another networks, then you can use the internet. But the device is connected to the Ethernet, and if the device, if that network is having a communication with other network through satellite, we will call it as internet. Okay, so that's why if you open any system and if you check the internet properties, there you will observe the status of the Ethernet. You will not see as internet. Okay, and of course, so many features are there. Wired communication or wireless communication depending on the security. So this is how, again, coming for the wireless and wired LANs. The difference is, for wireless LANs, we need an access point. That is nothing but Wi-Fi router. Whereas wired LAN, we will use a switch, Ethernet switch. So this switch is communicated with all the devices. Whenever if you want to transfer the data and if you want to make a communication with other system, we will use the switch as a medium. And next, coming for metropolitan area network, this is just like our disk cable connection. There will be one main office, and from that main office, by using separate junction boxes, they will make a communication. For example, we know about GeoFiberNet and XL FiberNet, but there is some local networks are there called XL. XL is one. Recently, I came to know that about that one. XL. XL broadband communication. What they will do is, it's actually metropolitan area network. If you want same XL internet connection in another city, in another state, you cannot find there. Actually, it is a MAN, metropolitan area network, where that man is having communication, where that man is connected to the internet, and they are providing the net for us. Active fiber net is there in so many areas, but earlier when ACT was started, it is also MAN. They are supposed to provide the internet only for that particular city. Later on, ACT fiber net was installed in one city, then moved to another city. Like that, they covered overall India right now. I mean, overall state and overall state, both Telugu states. I don't know whether it is there in other states or not, but they are like that. ACT was developed. Of course, Jio and Airtel XL broadband, they are different. So coming for like that, there are some local internet service providers also there. Best example is XL. XL is actually MAN. They will cover only up to 50 to 100 kilometers in a particular city, and they will get the internet by making their satellite antenna with internet connection, and they will receive the data and they will pass the internet for us. That is the best example for MAN. Coming for the wireless area network, there is another wide area network. Whenever you are connecting more number of systems, which are covering throughout the country or the continent, we can call that complete network as wide area network. We can call Geo fiber network as Geo WAN, Airtel WAN, but this has to be communicated with the internet to pass the information. So here it contains transmission lines and switching elements. Transmission lines will transfer the data, that is nothing but in the form of bits, from one system to another system, and switches are there to communicate two or more transmission lines. Actually, originally, subnet is the collection of routers and communication lines that moves packets from source host to the destination host. So please listen, please remember that we can call the system as a host. Okay, whatever the devices are connected in the network, we cannot call all the devices as host. Whatever the device, when the device in the network is having capacity to take the input, process the data, and if it gives the output, then only we can call it as host. Generally, in the network, there may be printers, scanners, Xerox machines, computers, so many things may be connected. We can call all them as devices, but we can call host, we can call computer as a host. Why? Because computer is the only device. It can take the input, it can process, and it will give the output. So we can call it as a host. So we cannot call printer or we can't call scanner as a host. Host is a device. Host is also an electronic device which is connected in the network. It can take the data and it can process the data and it will give the output. So that only we can call it as host. Only such devices are called as host. And so, for example, this is a WAN for Australia. Of course, I copied this image from the textbook Tenanbam. So, for example, if any system present in one country and one place wants to transfer the data to the system in another place like Brisbane to Perth, they must use this wide area network. If this Australian system wants to send the data to the Indian system, there will be another wide area network for the India. Both the WANs are connected to the internet, then only they can transfer the data. Okay. And coming for the network, so this is about network hardware. And coming for the network software, the first computer network was designed with the hardware as the main concern and the software as an afterthought. And I mean, earlier, while constructing the network, all the people were concentrated on the hardware only. They were not supposed to use the software. Whenever network software came to the existence, the strategy, of course, network hardware was no longer works. Network software is now highly constructed. Why? Because here, no need to worry about the hardware. Simply, if you are having one wide communication or wireless communication, that is the network. And whatever the procedure and whatever the process information exchange, whatever you want, you can use by software only. For example, for Wi-Fi, there are 10 devices are connected. We can give the internet only for 2 or 3 devices with the help of the MAC address. By using the software, we can object another system to enter into our network. We can send the data to only particular system. There are so many functions like helps to set up and install computer networks, enables user to have access to network resources in a seamless manner. It will allow administrations to add or remove users from the network. With the help of this software, we can do all these things. Admin can add all the systems to the internet. He can disconnect all the systems from the internet. In earlier days, if anyone wants to disconnect the device from the network, they must go and remove the cable. Right now, no need. Simply, they can block that IP address. Right? So virtualizations, virtual network, all this came to existence because of network software only. So to design network software, there are some different types of protocol hierarchies are there. So in this protocol hierarchy, we will follow the layered technology. So what actually layered technology is, this is how layered technology will be there. whenever one system wants to send the data, host 1, host 2, the data has to pass among the layers, so many layers from source side, and it will enter into the physical medium, whether it is wired communication or wireless communication. And again, at the destination side, it will pass among all those layers and it will reach the destination. So why this is needed? Why this is needed is because whatever the data sending by the sender, for example, from the source, you will send the data like my name is Krishna Kishore, or DOC file or MP3 file or video file, whatever the file you wants to send the data, you will send to the particular destination with the address from host 1 to host 2. The data has to be converted into so many ways. Why? Because the data will not transfer as it is to the physical medium. It has to be converted into binary form like zeros and ones. So to not only network must take care about the data protection, data security, data transmission, and data should not be lost. No one should see your data. You are sending the data from source to the destination with the destination address. So no one can access the data from with this medium by entering as an intruder. So there are so for that purpose, one layer is responsible for one thing. So whatever the layer at the source side will be same at the destination side. So the corresponding layers agreement is called as protocol. Protocol is nothing but rules and regulations to be followed by the layer at the source side and at the destination side. Whatever the rules following by the layer 5 same rules should follow by the layer 5 at the destination side. Whatever the rules following by the layer 2 at source side, same rules should follow by the layer 2 at the destination side. So such agreement will be done between corresponding two layers from source side and destination side, and we are calling that agreement as a protocol. So in such a way, of course, by designing this to construct any computer network, we will follow the layered technology only. There are two reference model. One is OSI reference model, another is TCP/IP model. To construct a network, computer network, we can follow the layer. We will follow layered technology only. In that layered technology, there are two reference models are there. We can follow either of the reference model. Okay, in one model there are 7 layers, in another model there are 5 layers. We can follow any of the model, but it is must and should to follow the layered technology only. Why? Because in the layered technology only, each and every layer will make a communication with another layer at same side with the interface. With the help of this interface, low level layer will provide the services to the high level layer. So for example, here you are sending one MP3 file. That MP3 file must receive by this lower layer, and this data should receive by this layer. This data should receive by this layer. Like that, each and every layer will provide a service to its upper layer with the help of this interface. And the interface name is, this is layer 2x3 interface. This is layer 3x4 interface. This is layer 4x interface. Like that, at the destination side also, each and every layer will provide service to its higher layer with the help of the interfaces. So both source and destination will make a communication with the physical medium, either by wired communication or wireless communication. So coming for the while designing this layered technology, there are some design issues are there, like reliability, scalability, addressing error control, and flow control. Reliability means providing the trust. Scalability means how many systems are there, to how many systems the data has to be transferred, what is the size of the physical medium, and all those things comes in the scalability. Addressing is very important, from which address to which address it has to be transferred the data. Error control, the data should follow flow without any errors. Please remember, in computer network language, error will not depends upon the data. I mean, for example, in your programming language C or Java, what is an error? When you are executing, the compiler will find some error, like some syntactic error or systematic error, that there is an error in the program. But coming for the computer network, error means whatever the data sent by the sender must reach to the receiver. For example, the data is 10101010 from the source. And while reaching at the destination, instead of 101010, if 10100010, so one bit is modified, means there is an error. Whether the file is the corrupted file or correct file or nothing, it's not a matter. It does not take care by the network. Network will see whatever the source sending the data. For example, save your PDF file with the .mp3 extension and transfer the data through mail or through WhatsApp or anywhere through internet. The same data will reach at the destination side. If we open that file, it will not execute because the software in that system will not support that file format. But the data will reach, right? So whether whatever the data sending by the source reach to the destination. If there is any error means if there is any modified bit in the data, then we can call it as error. So that error control is must and should. And coming for the flow control, there may be the fastest sender and slowest receiver. The speed should be controlled. The flow should be controlled between fastest sender and slowest receiver. So these are the design issues while constructing the layer, while we are following the layer technology. Of course, routing. Routing means so many will call it as routing, but actually it is not routing, it's routing. Routing the packet from source to the destination by following different types of algorithms. For example, there are 60 students are there in our section. 60 students, because for any workshop or for any event, these 60 students should reach another college which is located at Hyderabad. These 60 students can follow any of their route. For example, one fellow will come from Guntur to Hyderabad via Vijayawada. One fellow can come from Nasraupeta. One fellow can from another route. They can choose any path. But at the destination side, roll number 1 to roll number 60 should be at the auditorium. So from source, 60 students started departure, and at the destination they arrived, right? Whether all 60 students arrived or not, this is the main thing. So they can choose whatever the path they need, depending upon the traffic jam, or depending on route, depending on the vehicle, they can follow anything. So these will be defined by the routing algorithm. So many routing algorithms are there. Those algorithms will say which route has to be chosen. Okay, there may be multiple paths from source to the destination. The large data element can be divided into small data chunks, and we are calling each and small data chunk as an packet. So each and every packet can choose their own path. So routing the packet from, but each packet should know the destination. Each roll number should know the destination. Then only can reach the destination address. Like that, we are dividing one large amount of data into small data chunks, and we are calling each and every data chunk as a packet. So this data packet contains the destination address, and it will reach the destination. So how the packet will route how through which path the data packet will reach from source to the destination, that depends on the routing algorithms. Congestion means overloading of network because of too many computers wanted to send too much of traffic. For example, there is only one path, so many people wants to use the same path, then there will be the occurrence of traffic jam. We are calling it as congestion. That more traffic is nothing but a congestion. We can control that congestion also. How can we control? For example, if that path is busy, we will guide the another packet to choose another path. If all the paths are busy, wait for some time. You cannot transfer the data. If your results are out, you will download the results. All of a sudden, all the students went to the system and they will ask for the results. The server will be busy. Actually, server is not busy. The path is busy. The path get traffic jam. The same path is using by n number of students. That's why congestion occurred. This can be controlled by using some softwares like please wait. Server is not available. Please wait. Some path is not available. They will give some message, and we will wait. I will give one example. Recently, not only recently, if you go for any websites, they will give you some time for you to wait, and unless and until that server give you some chance for you people. Quality of service will be provided if you do the congestion control and route the packet from source to the destination. And security, major factor of data communication is to provide that security only. Threats like eavesdropping and suspicious alertation of messages by confidentiality and authentication. So whenever if you are talking, if you are speaking with your friend in telephone, if anyone from first floor, if you are speaking with your friend by using the telephone in the ground floor, if any other fellow or using the same telephone in the first floor, and if he is listening whatever you are talking, this is nothing but your data is getting miscommunication. Your data is getting hacked. So like that, the data should not be hacked. For that purpose, we will use the mechanisms like confidentiality and authentication. Confidentiality means whatever the data you are sending, it should be confident, and authentication means whoever the authorized person, he can only access by providing user ID and passwords. Data transmission can be done either in, this is very important, and I will definitely complete this one, connection oriented and connectionless service. Connection oriented service is different, connectionless service is different. What is the difference between these things? Please don't get confused. Connection oriented and connectionless is same as wired communication and wireless communication. Wireless communication means we are connecting the devices without using cable. Wired communication means we are connecting the devices with the help of the cable. That is different. Connection oriented and connectionless is different. Connection oriented service will always say that whenever if you want to transfer the data, first establish a connection. For example, if you want to talk to anyone, first you will say hi. He will also repeat hi. Then you will exchange the information. That is connection oriented handshaking methodology. If one system wants to send the data to another system, first he will make a communication and ask for connection establishment. Then connection will establish between these two systems. Then only he can transfer the data. And after transfer the data, he will use the connection. Connectionless service means whatever the data wants to send from the source to the destination, just with the help of the destination address, he will send the data. Whether the data packet reached the receiver or not, it's another issue. That is connectionless. Best example, if you want to make a call, what you will do, you will dial the number. One connection will establish from source system to the destination system. You will talk to each other. After that, you will disconnect. This is connection oriented service. If you want to, this is how you will pass the information. And if you are passing the information by using SMS or WhatsApp, okay, leave about WhatsApp, by using SMS, you are just sending the data by typing in your system, and the message will pass to the receiver. So this is connectionless service. Whatever the message you are sending by SMS is the connectionless service. Whatever the message you are transferring by using voice over IP, it is nothing but connection oriented service. So connection oriented service is actually highly reliable network when compared with the connectionless service. So there will be, of course, just about connection oriented and connectionless. And coming for the reference models, 1 second, please.
Sure, sir.
Okay, my screen is visible. My
Yes,
screen
sir,
is
it is
visible.
visible.
Yes, sir. Okay, sir. Thank you. Excuse me. So coming for, let us complete the reference models. Actually, coming for the computer network architectures, so we can follow either of the reference models. One is OSI reference model, another is TCP/IP. But coming for the OSI reference model, this is the Open System Interconnection Reference Model, which is standardized by ISO in 1995 itself, and it follows all the standards provided by the networking administrative services. And this is huge, more number of people will prefer this one. This is because open systems, so anyone can use this interconnection technology without any permissions. So there are some principles like a layer has to be created where the different abstraction is needed. Each layer should perform a well-defined function. The function of each layer should be chosen with an eye toward defining international standard protocols. The layer boundary should be chosen to minimize the information flow from access to the interfaces. The number of the layers should be large enough that distinct functions need not be thrown together in the same layer out of necessity, and small enough so the architect does not become unwieldy. So just I'm reading out the principles. Why? Because we will go through the explanation instead of those principles. So coming for the OSI reference model, total there are 7 layers are there: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Each and every layer each and every layer at the source side, whatever the layers are there, each and every layer at the source side and of course at the destination side will provide a service to its upper layer with the help of the interface. Okay, and whatever the data where application layer is the layer where the user is interacting, we can call application layer as end user applicant layer. Why? Because the user will communicate with the system through the network with the help of this application layer only. This application layer is responsible for so many different types of applications like by using different protocols like HTTP, FTP, SMTP, file transfer protocol, simple mail transfer protocol, hypertext transfer protocol. By using so many protocols, whatever the data he wants to send, the user will send by using this application layer only in the network. Each and every layer at the source side will make an agreement with its corresponding layer at the destination side. And we are calling this agreement is not as a protocol, and the name of that protocol is application layer protocol. Data belongs to this protocol will stored in separate data unit called application protocol data unit. So what are the rules to be followed by this application layer and this application layer are there in this data unit, that is APDU, application protocol data unit. Same presentation layer protocol data unit, session layer protocol data unit, transport layer protocol data unit. These four layers are called point to point layers. Why? Because from which point, from which layer the data is transmitting to which layer, and what is the form of the data in this layer and what is the form of data in this layer can be known by anyone, either or the person at the source side or the person at the destination side. But coming for these three layers, we can call these three layers as network to end-to-end layers. Why? Because whatever the data has to transfer through the physical medium. Here there will be one physical medium will be there from source to the destination. Whatever the data to be transferred, we use that physical medium only. So whatever the data has to be transferred, it has to be protected. It has to be divided. It has to be follow some rules without errors and flow control. For that purpose, we here internally they are maintaining another sub network. So in again their subnetwork, they will make an agreement with each and every layer in the subnetwork, network to network, data to data, and physical to physical. So they will follow the same rules and regulations at the source side and the destination side. From here, whatever the data you are sending from application layer will be stored in application protocol data unit. Like that, whatever the data you want to send to the data link layer, it will be in the form of a packet. Packet means it's nothing but a data chunk. Huge amount of data is divided into small data chunks, and we are calling each and every data chunk as a packet. Okay, this packet will send to the data link layer, and the data in the data link layer will be in the form of a frame. Actually, the shape of the frame contains three parts: head, payload, tail. Of course, there is an explanation for each and everything in the coming slides, but as there is no much time, I am briefing here itself. Please understand. And coming for the data link layer, the data will be in the form of a frame. Packets will convert into the frame. We will call that procedure as framing. How it will be done? In the frame, it contains three parts: frame head, tail, and payload. Actual data belongs to that packet will be in the payload. Frame head will contains to which address this frame has to be passed. Tail will contains its frame number and everything. Why? Because while transferring from source to the destination, each and every packet which is in the form of a frame and which will convert into the physical raw bits, zeros and ones, can choose whatever the part they need from source to the destination. For example, if there is no numbering for each and every frame, frame 1, frame 2, frame 3, frame 4, if you are transferring these 4 frames, of course, at the destination side, frame 3 may reach first, frame 2 next, frame 1 last, frame 4 next, like that. So these has to be rearranged again. So for each and every frame, numbering is compulsory. So in the data link layer only, framing, error control, and the flow control will be done. And data link layer, physical layer will receive the data from the data link layer. It will transfer, it will convert that frames into physical bits. That is nothing but zeros and ones. These zeros and ones will transfer to the physical medium. And again, at the destination side, it will enter into the physical layer. And here, these zeros and ones will reconnected into they will convert into the frames will convert to the packet will convert into the transport layer of protocol data unit rules and regulations, and transport layer will send the data to the session will send the presentation to application layer is nothing but applications, whatever the applications we are using at the source side or destination side to send and receive the data. Presentation layer will receive the data from application layer in the form of in different form like a compressed WinZip, WinRAR. So such a format will be followed. And session layer is responsible for token management. Token management means whose track is next. For example, so many persons can send the data. For example, there is one application called exam result announced or get hall ticket download. For example, all the people are connecting through a common software. Gate 2022 one website is there, and you will connect to that website. And for thousands of people are asking by using the same application, I need to download my hall ticket. So here, whose track is next? Whoever enters first and who is having high speed, he will get first chance. Next person next. From your system, you are asking for download, or from my system asking for download. Whose track is next will be decided by the session layer. Transport layer will say whether you are transferring the data in the connection-oriented service or connectionless service. Connection-oriented service means making a connection first and then asking for the data. Connectionless service means you will ask the data and they will reply, or anything it may be. For example, if you are searching anything in a Google, it is a connection oriented service. By opening Google, I'm searching for computer networks and Anubhav textbook. He will give some websites. I will log into that website. I will ask for the PDF file. So it will establish connection. Download will be done. It is connection oriented. For example, if you are opening Gmail and you are sending a mail, so the mail will send from your system to other system. It is connectionless. Here also transport layer will take care and it will say it is connectionless. And whenever you are asking any downloads or anything, it is connection oriented. This will be taken care of this will take it by the transport layer. So this is how OSI reference layer will be work, and these are the different layers of functioning. And coming for the TCP/IP reference model, instead of using 7 layers, here we will use only 5 layers. The work of application layer will be done by the here like that. Here there are 5 layers are there: application layer, transport layer, internet layer, and link layer. No physical layer. So whatever the work doing by application layer in the OSI reference model, the same application layer will be do in the TCP/IP model. Whatever the work, whatever the responsibilities of presentation session layer are there in OSI reference model, those are doing by the presentation session transport layer. All this will be taken care by the application only. Transport responsibilities will be taken care by the transport. Network responsibility will take care by the internet. Data link layer and the physical layer responsibility will take care by the link layer. So these are the 5 layers of the TCP/IP model. Of course, so much of data is there for explain, but as there is no much time, I'm ending here. Okay, I want to say about the network devices. So there are so many different, to connect a network, we need a devices. There are so many network devices like repeaters, bridges, routers, gateways, multi-protocol routers, hubs, switches, and modems. So what are these? I will give you a small brief definition about these things. Repeater is a device which will strengthen the signal. For example, whatever the data we are receiving, if there is if you are out of the range, the receiving signal will be less, right? If you use the repeaters there, the transmission signal will again strengthen. I will give an example. There is Wi-Fi modem in your house, and up to room 1 the signal is good. If you want to use the data from room 2 where the signal is slow, you can do one thing. You can switch on mobile hotspot in your mobile device, keep it in room 1, and you can connect to this mobile instead of connecting to the modem. So here mobile is acting as a repeater. Why? Because there is here you are receiving the signal from your mobile from room 2. As there is less signal strength from the modem, you are using mobile device as your repeater. So repeater is one device which will strengthen the signal. If you are out of coverage, if you are using the repeater, it will strengthen the signal. And bridges, whenever you are, if you want to connect more than one LAN, 1 or 2 LANs into a single LAN, we will use a device called bridge. Router will route the packet from source to the destination. So what the router will do is, whatever the systems connected here, they will send the data, and this router will pass that data to the system in another network with the help of internet service provider. Only the thing is, if you are using router at the source side, and what are the rules and regulations following by this router should follow by the router at the destination side also. If the rules and regulations following in this network and this network are different, instead of using router, you can use gateway. So gateway is nothing but, instead of using router, we will use the gateway. So how the gateway will work is, there is one a rule that what are the rules are following at the source side should follow, same rules should follow at the destination side. Then only router will come work. If the rules are different, instead of using router, you will go through the gateway. So it will support. and multi-protocol routers also there. So multi-protocol routers will help for only multiple. I mean, for example, there are so many different types of rules are there. So among those rules, it will support. I will give an example. While you are traveling on highways, you will see some transport vehicles, lorries, national permit, South India permit, only Kerala, Tamil Nadu, Andhra Pradesh, Telangana, like that they will mention. What it means, national permit means that vehicle can move throughout the nation. Karnataka, Tamil Nadu, Kerala means they can roam only in such areas. And if it is not having any such permit, for example, our cab, yellow board, it can roam only in our state. It should not go to another state. For example, Telangana registered cab or car with yellow board cannot go into another state. If they want to move there, they should take the permission of the RTO office by paying some amount. So here, this cab is called router. It can work if they are following the same thing over there. Multi-protocol router means the vehicle with multiple states permission, we can call it as they can roam over those states. They cannot move throughout the India. If they want to move throughout the India, instead of using multiple protocols, we are using the gateways. So national permit, like that. Hubs. If you want to send the data to all the connected systems in the lab, we will use hub. Without to which address, whatever the data you are sending, the data will be received by all the system if you use hub as a central device. Instead of using hub, if you use the switch, you can send the data to all the devices, or you can send the data only to particular system with the help of the address. Of course, in latest labs, everyone using switch instead of using hub. The difference between hub and switch is hub will transfer the data to all the devices. Switch will transfer the data only to the particular IP address, whatever the address mentioned by the source. If you mention all the addresses, it will send to all the devices. That is about the switch. And modem. Modem is very different type of router where it contains modulation and demodulation. In our homes, if the router contains antenna, we can call it as modem. Why? Because modem will send the data by converting digital wave format to analog wave format and analog wave format to digital wave format. If in your home, if your modem is having antenna, so what it will do, whatever the data is receiving from LAN, ACT fiber net, optic fiber, it will convert the data into waveform so that you can receive through your mobile device, which is connected through a Wi-Fi. And if you are sending the data from your mobile device to any another system, either by mail or by WhatsApp, so the analog format will receive by that antenna, and that modem will convert that analog waveform into the digital form, and it will send the data to the optical fiber. So for such use, we will use modems. Coming for CSU, DSU, this is another network device. How this device will help? Channel service unit, data service unit. How this device uses? There is a LAN where all the systems are connected. The technology, rules and regulations following by this LAN is different when you compare with the WAN, wide area network. So to make the use of this LAN in WAN through internet, we need a separate device called CSU, DSU. This CSU, DSU, channel service unit, data service unit, will provide a service. Whatever the data you are using, whatever the whenever you are, if you want to transfer the data from your system, which is connected in the LAN through WAN by internet, so the rules and regulations are different. So for that purpose, we need a separate device called CSU, DSU unit. Of course, these services providing by the access points and routers in these days. Next one is NIC. This is another network device called network interface card. This card will helpful only if it wants to support any particular device. I will give an example. In earlier days, I will give my own example. When I am in 2007 January, I purchased my first personal computer with a CRT monitor and CPU. And if I want to watch movies, I mean want to watch TV, nowadays there is a huge usage of internet. On those days, it's not like that. I purchased 1 GB memory card for 600 rupees for my multimedia mobile. But right now it is very easy and we can easily access through internet because of internet paying amount like that. But earlier days, it's not that much easy. If you want to watch any programs, we need a TV. So for my CPU, I insert one NIC, network interface card, where it contains TV tuner. We will call it as TV tuner card. The TV tuner card will connect to that system and disk. Why? Because there is no interface for disk cable to connect to CPU. To connect that this cable to my CPU, definitely I need a TV tuner card, and I call the TV tuner card as network interface card. Do you understand what I'm saying? For example, if you want to play the games, you need to install graphics card. It is also network interface card. And next one is wireless access point. That is nothing but Wi-Fi. This is also a network device, Wi-Fi routers, which we will see in our colleges or anywhere. So it contains one wireless access point. It will establish one wireless local area network. And next one is transceivers. Transceivers will work with infrared radiation. I mean, the best example is if you are accessing anything with the help of your remote, TV remote, by using TV remote, you will change the channels. By using AC remote, you will make a communication with the AC. Like that, if you want to transfer, they need, for example, if you are moving in a car, with the help of the IRD communication only, it will find out any obstacles are there. So we can like that by using infrared radiation, infrared communication. If you are making communication, if you are communicating two or more devices, we can call it a transceivers. What is the of course, a AC remote is not a transceiver. Why? Because AC remote contains LED, which will send the data, and the AC mission contains receiver. It will receive the data. If you are providing both transmission LED and light emitting diode and receiver in one device, we can call such device as transceivers. And next one is firewall, where firewall is nothing but better know about in our computer. If you want to stop anything, we will use the firewalls. Firewalls will not allow all miscellaneous things into your system. All this comes under the network devices, proxies and proxy servers. So coming for proxy is nothing but alias. There are some websites, there are some servers which don't want to share their identity. What they will do, for example, Google server is located at somewhere, we don't know where the Google server is. Example, for example, I am having one server and I want to provide a service to the clients, but I don't want to reveal my IP address. So what I can do, I can use proxy server. So proxy server is another country. I am at another country. With the help of what about the requests and responses are sending and receiving, you will send with my name only. Proxy server will be there. For example, my Microsoft server is there with same alias name. He will create one proxy server. The proxy server will receive the request and he will give the responses. How? That proxy server knows where actual server is. So there is a communication between main server and proxy server. Server will not maintain any communication with other clients. This proxy server will maintain communication with all the systems. This system will send the data request to the proxy server. Proxy server will gather the information from the main server. And again, as a response, this proxy server will give the response to the client. Client knows the server address as proxy server address only. He cannot know where the main server is there. Like that, proxy servers will work. This is about introduction about the computer networks. I think I am done. Is there anything to say?
Thank you so much, sir, for your wonderful session.
Thank you, sir.
So participants, if you have any questions, you can type in the chat box or you can raise your hand so that I can unmute you. I think no more questions, sir.
Yes, sir.
Thank you so much, sir. It was quite very good information you have given in the PPT, and your explanation is also very, very good. Thank you, sir.
Oh, thank you very much, sir. Thank you, sir. Can I leave, sir?
Yes, sir. Yes, sir. You can leave.
Okay, sir. Thank you.
Yeah.
Thank you, guys. Thank you, participants. Bye.
So all the participants, feedback form is posted in the chat box of the Zoom and YouTube. You can fill it, and those who have filled can leave now. Thank you. All of you, please fill the feedback before leaving. Those who have filled the feedback can leave now. Thank you. Feedback form is there in the chat box of Zoom as well as in the YouTube. Please see it and fill it. It will be open for next 10 minutes.